Okay, so finalizing our study of limits and continuity, we are going to discuss the intermediate value theorem. And the intermediate value theorem relies on the continuity of a function. And the theorem is stated as follows. If f of x is continuous on a closed interval, a to b, then the function has at least one c value on a to b, such that f of c is between a and b. So graphically, this means that no matter what my function looks like, if my function is continuous, my graph will pass through every value between a and b at least once. So, in order to work with IVT, we need to establish that we can use the intermediate value theorem by showing that the function is continuous. You need to show that the function value at each endpoint is, and back up. So, generally, we're going to use the intermediate value theorem to prove that a root, remember this is where it crosses the x-axis, exists on some interval of the domain. So we do this in a three-step process. We establish that we can use the intermediate value theorem by showing that the function is continuous on the interval in question. We show that the function value of each endpoint is the opposite sign, so one's positive, one's negative. And then we state that the intermediate value theorem has proven the existence of at least one root in the interval. So, for example, if we have the continuous function f of x has f of 1 equals to 5 and f of 3 equals to 10, the intermediate value theorem would guarantee the existence of at least one value between 1 and 3 for every y value on 5 to 10. So let's go ahead and use IVT on example 1. So we're going to use that IVT, f of x is equal to x cubed plus x. So we can state that f of x is continuous on the closed interval 1 to 2 because f of x is a polynomial. Next, we need to evaluate what f of 1 is. So f of 1 is going to be 2. F of 2 is going to be 10. And so by the intermediate value theorem, we know that since f of 1 is less than 9 is less than f of 2, there exists a c on 1 to 2 such that f of c equals 9. All right. So, example 2 is asking to show that f of x has a 0 on the interval 0 to 1. So we know that f of x is continuous on 0 to 1 because f of x is a polynomial. So now f of 0 we can see is negative 1. F of 1 is going to be 1 plus 2 minus 1, so that becomes positive 2. Since f of 0 is less than 0, it's less than 2. Sorry, less than f of 1, there exists a c on 0 to 1 such that f of c equals to 0. So the second part of this question asks to find the value of c. So we know that f of c equals c cubed plus 2c minus 1 equals to 0. Now, this we would need to use a calculator for, and we would find then that c, if I remember correctly, okay, so we are looking for where f of c equals right. So the second part of this question is asking to find the value of c that is guaranteed by this theorem. So we know that we have f of c equals c cubed plus 2c minus 1, and that equals 0. We would have to use a calculator for this one, and we would find that c is equal to 0.4534, which is on the interval from 0 to 1. All right, let's look at one last one. So we have f of x is x squared minus 3x minus 1. So we know that f of x is continuous on 0 to 6 because f of x is a polynomial. So f of 0 is negative 1. F of 6 is going to be 36 minus 18. So 18 minus 1 is going to be 17. And so we know that since f of 0 is less than 2, which is the value we're looking for, which is less than f of 6, therefore, there exists a c on 0 to 6 such that f of c equals to 2. So now we solve this function. So we have f of c is c squared minus 3c minus 1 equals to 2. So c squared minus 3c minus 3 equals to 0. And now we need to use the quadratic formula for this because it doesn't factor nicely. So c equals to 3 plus or minus the square root, negative 3 squared, so 9 minus 4 times negative 3 times 1 over 2 times 1. And so we have c is equal to 3 plus or minus the square root. This is 9 plus 12, so square root of 21 over 2. Let me clean up that square root just a little bit. Okay, so you can see that square root of 21 is definitely going to be more than 3. So we have both solutions of c plus this, sorry, not c. We have both the solutions of c equals 3 plus the square root of 21 over 2, and c equals 3 minus the square root of 21 over 2. This one is not in our domain, so this is our only solution within our domain.